Guys, what is going on? Get some work done in the morning. We are gonna learn. We're gonna learn. So, what do we got today? What did we do yesterday? Let's hop back into it. I've had a long morning. I've been up since about 6 a.m. Just getting after it, folks. Really buttoning things up. And for instance, I had a guy comment on some of the videos that the audio went out. I don't know what's going on with the software that I printed the audio out. I missed it entirely. That the tail end of two videos didn't have audio. Super something that just flew right over my head. So fixing those, and what I'm going to do on those is just have a link in the description. I can re-upload the video, but then it would all be out of order. So I thought that would kind of mess with things. So what I actually ended up doing is or what I'm going to end up doing right now, I'm reprinting the videos right now, but what I'm going to end up doing is putting the links in the description, and then hopefully also in the comment section, one or both. And that way, you guys still have access to the information, and it's all done proper. So that I thought was the best solution for that approach was not deleting the videos, because then, like I said, they'd all be out of order, but then just attaching the unlisted. They'll be unlisted, but there'll be a link available to see the rest, the audio. So I hope that helps. And yeah, let me know if I have any other mistakes. I mean, because the biggest thing is making sure I'm of value for you guys. That's the first and foremost thing. So let's dive in. So we're learning errors and exception in Python today. You've probably encountered some errors in your code. I have. I've encountered errors in code and in videos and in real life. They would just went over one. This is perfect. This is perfect. From time to time, if you've gotten this far in the course, in Python, there are two main kinds of distinguishable errors. You have syntax errors and then exceptions. Syntax errors, you probably know these or what these are by now. A syntax error is just Python interpreter telling you that the code isn't adhering to proper Python syntax. This is not valid code, so it will error. If I try to run this sentence as if it were code, I would get this error. It's invalid syntax. So it's saying if we just put a bunch of text here, it'll say something like this, invalid syntax, boom. Okay, so we have try except blocks. So even if your code has the right syntax, however, it may still be causing an error when an attempt is made to execute it. Errors detected during the execution are called exceptions. It can be handled gracefully by your code. You can even raise your own exceptions when bad things happen in your code. Use a try except pattern for handling errors. You could try 10 divided by 0, and the exception is we can't divide by 0. So the try block is executed until an exception is raised or it completes whichever happens first. In this case, a divide by 0 error is raised because division by 0 is impossible. The except block is only executed if an exception is raised in the try block. It then exposes the exception as data, E in our case, an event, so that the program can handle the exception gracefully. Okay, awesome. So the assignment here looks like we're going to be given some sort of error, I imagine. One of the calls to get player record is throwing a error for player ID. So we'll run it and see which one it is. Player ID not found. Okay. So change the code in the main function to make safely. So don't edit below this line, but it says we got to change code in this function. Oh, we got to change code in this function. Okay. So I believe what we can do is say try, right? And then we could say except. Sorry guys, I feel a little bit tired right now, to be honest. I slept good though last night. I had such good sleep. I was in bed probably 9:30 watching some blockchain videos. It's this new habit I got. I study the blockchain in the evenings, like going to bed on the projector. I'll be super exhausted. Eyes just closing on me, trying to keep them open as much as I can to just learn. And then boom, I wake up with knowledge just instilled in my brain of like, oh, here's how hashing functions work. It's pretty fun. So, okay, but let's see. Let's get back up into the speed. I'm pounding back a bunch of coffee. Boom. Okay, so we've done the try. We try to print these. Boom, 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 boom. And then we get an exception, which is going to be here. So it looks like we've done it. The fourth ID looks like it's not found because there's no player ID 4. If player ID equals 4, we'd have something. We don't have something. So let's see if that works. Sweet. Little coffee sip for that one, right? A little coffee sip for that one. All right. Let's say that's some good old mud water, right? So if no exceptions are raised in the try block. Ooh, all right, let's see. The program crashes. The except block won't execute if no exceptions are raised in the try block. Does that mean it worked, right? The code ran. I'm not sure, guys. I'm not sure the answer to this, to be honest. So we'll click one. Oh, look at that. First take Drake. First take Drake. So the except block won't execute. So if no exceptions are raised in the try, so is that what they're saying? They're saying there's no exceptions raised here. It worked. 10 divided by, let's say it's 10 divided by 1 means that it means the except block won't execute. So this part won't execute. Okay, that makes sense. Just an inverse way of asking that question, I suppose. If an exception is raised outside of a try block, the program crashes, right? If it's outside of the try block, would it crash? If an exception's raised inside of the try block, it would throw the exception, right? Let's see. I'm going to go for this one because it's saying the except part will handle it, but this outside of a try block, it makes it feel like the program would crash, but I don't know if that's important, if they mean outside of everything or inside. I don't want to look bad, folks. Okay, we made it. We did it, folks. We did it, and we're level 17 now. This is great. We're cruising right along. We're picking up a little speed, guys. We're picking up a little energy in the morning. Come on now. Okay, so raising your exceptions. Errors are not something to be scared of. They're really not. It's just you're just building code. You're building software. You're knitting a bunch of digital bits together. Basically, you're building a pattern. You're constructing. You're architecting. You're screwing giant lug nuts through a steel beam of software. That's what we're doing. And if the steel beam isn't proper, you got to take the lug nuts out. Make sure we readjust, drill some new holes, make sure the thing's proper. So that's all we're doing. That's all we're doing when we get in there. We just notice the beam's a little wobbly. So every program that runs in production is expected to manage errors on a constant basis. Our job as developers is to do some error handling in a graceful way and in a way that aligns with our users' expectations. Okay, so errors are not bugs. An error could be something just timed wrong or something. When something in our code happens that we don't expect, we should raise our own exceptions. For example, if someone passes in a bad input to a function we write, we should not be afraid to raise an exception to let them know that they did something wrong. Just in an email field, you have form validation. If we have a user names the email, put in your email. Someone doesn't put in an @ symbol or they don't have an email. We need to let them know. An error or exception is raised when something bad happens, but as long as our code handles it as the user expects it to, it's not a bug. A bug is when code behaves in ways our users don't expect it to. So if someone puts in a bad email address, we should let them know. Do the little red outline on the box, throw an error, say, hey, don't do that. That's not a bug. That's an error being raised. So for example, if a player tries to forge an iron sword out of bronze metal, we might raise an exception and display a message to that player. Hey, you can't do that. You need iron. You need iron to make an iron sword, not bronze. So however, that is the expected behavior of the game. It's not a bug. If a player can forge an iron sword out of bronze, that may be considered a bug because that's against the rules of the game. Okay, so here's the assignment. Basically what it's saying is we have to go one abstraction higher. So when we're building the code, first we need something that works, right? We need a function that just works. Let's say you're building a calculator game and you're like, hey, or multiple choice thing similar to this, how we go through multiple choice answers. So first we just need to build the code that even works, that someone can click a multiple choice answer, a calculator game of if I use the X looking operator or the plus operator, what does the plus operator do? We need to say that's addition, but we also need to let the users know, hey, there's wrong answers. It's not a bug, but if you click on the division when it's an addition answer, we need to let them know that's the error. That would be a multiple choice game, but there's also other ways to show errors to people. Like I said, the email operator thing or the email validation. As they said, if someone tries to make, let's say you're playing Minecraft, you're trying to build a diamond sword with wood, ain't gonna work. Or cobblestone, it's not gonna work. So if a player ID that doesn't exist is passed into the getPlayerRecord function, we need to raise but not handle our own error to alert the caller of our function that the player they're looking for doesn't exist. The exception should say player ID not found. Okay, so if a player ID doesn't exist, it's passed into the getPlayer, we need to throw an error and say, hey, that doesn't exist. That doesn't exist. Okay, cool. So we'll raise an exception, I suppose. Maybe we could do this. Raise an exception. Player ID not found. Okay, let's try. Oh, nice. Got her done. So I hope that makes sense. It's like we we not only have to build the game or like we not only have to build the input forms or the backend server, like we not only have to build the thing, but we also have to build rules for the thing so people know how to navigate, right? So if you're building Roller Coaster Tycoon, you need to show people you can put things in the blocks where roller coasters can be built, but you also need to show a little X where they like try to build a roller coaster on a tree, and you can't build there. You can't do that. You can't do that. It's not a bug. That's logic showing them how to play the game, giving them errors, giving them feedback. So we have to do that as users or as developers for everything, right? Like I said, an email form, that's everything for everyone building profiles. If they build out, the wrong profile and they don't submit a username with their profile, we need to let them know. We need a name with your profile. So that's part of it, is giving them the error logic as well so they can navigate your software correctly. Okay, so raising exceptions review. Software applications are not perfect, and user input and network connectivity are far from predictable. Despite intensive debugging and unit testing, applications will still have failure cases. This is why we have retries. This is why we have fetching. This is why we have 404s, kind of all that stuff. So loss of network connectivity, missing database rows, out-of-memory issues, and unexpected user inputs can all prevent an application from performing normally. It is your job to catch and handle any and all exceptions gracefully so that your application keeps working. This is also why microservices were built. So only one part of the application would break while the other parts could still function. Okay, so when you are able to detect that something is amiss, you should be able to you should be raising these errors yourself, in addition to the default exceptions that the Python interpreter will provide. Okay, so let's see, which keywords triggers an exception in Python? Exception, right? Oh, raise. Here we go. Okay, cool. Good code doesn't need to handle errors. It should be error-free. I think it's false. But good code still handles errors. Yeah. Okay, so different types of exceptions. We haven't covered classes and objects yet, which is what an exception really is at its core. Excuse me. Got a little coffee burp thing. Okay, so coffee hiccup. We'll go into more detail into the object-oriented programming course that we have lined up for you next. For now, what is important is to understand is that there are different types of exceptions that we can differentiate between in our code. So we have exceptions. Looks like we have all sorts of index errors, division by zeros, exception as E, things like that. So, okay, we have the as keyword that we can use. Take a look at the assignment. Okay, so take a look at the get player record function. It raises an exception for negative player IDs. If the player ID is below 0 right here, on lines 9 and 10, raise an exception. Negative IDs aren't allowed. What is this? What is this? This isn't no jibber jab. Come on now. Come on. Okay, so complete the handle get player function up here. Should return the results of the get player record. But if an index error is raised, it should return that. Okay, cool. Okay, so let's look at what we need to do. So we have index errors. So try, accept, boom. I'm not sure what we necessarily need to try quite yet, but we will accept something. Okay, so we need to print. What do we need to print? The index is too high. Forget what we need to try. Boom, index is too high. Okay, so complete the handle get player function. It should return the result of the get player record, but if an index error is raised, is that what we need to do? Return the result of get player record. So we can say res or results, right? Return results. Player ID. Guys, I'm not sure. We're gonna take a peek at the solution real quick. Return get player record. I thought we definitely just did that. We 100%, and it was throwing an error. Why was it? Okay, so return get player record. Let's see. Yeah, it's still interesting. Do we need this part as well? The exception as E, return E. Let's take a look. Sure, I'm missing something. Okay, let's see. So return index. Oh, I see. I returned the actual print statement 1. That's not what we want. But okay, so we did need the exception. That's the biggest thing. Okay, so that was one of the biggest things, is we actually did need the print statement. Then we could at least see that we were passing something, but not. So with the exception, we're not allowed to pass in functions without an exception or something. Okay, that's good to know, or at least some relative understanding around that, right? Okay, try to understand why we need that. I'll let that one marinate in the back of the brain for now. Okay, so raising exceptions review. As you've noticed, there are many kinds of exceptions. guys, oh man, it's just a weird day for me right now. You know what I mean? Like, yeah, just exhausted, freaking. Oh my gosh, drinking coffee, slept so good, worked hard yesterday. Oh, today I have a talk today. I'm teaching a small lesson at the next ATX meetup today, which is super fun, on server-side rendering and contract generation with GraphQL and AWS AppSync. So I'm super excited. Should be a good time. I'm going to try to get some footage of it and put it part of the vlogs, or at least the next vlog coming out, or one of the vlogs coming out. Yeah, it's a huge moment for me, or at least just a small, like, win for me, small W. And super grateful for the opportunity. Super grateful for Silas for allowing me to do that. And yeah, should be a good time. So maybe that's why the energy's a little bit slow. I'm keeping it in the gas tank for later. So should be a good time. I got it up on the calendar here, so that's why I keep looking over to the right. Okay, so as you've noticed, there are many kinds of exceptions. Many specific exceptions are built into the language index error and zero division error, and almost all exceptions count as parent exception type, or excuse me, as the parent exception type. If you're interested in the official documentation on all the built-in exceptions, you can find a list of them here. So there's going to be a whole bunch, I'm sure. Base case, some exception, boom, there's buffer exception, arithmetic error, buffer error, lookup error. There's a bunch, it seems. Okay, so refer to the following code for the question. In the code sample, what will happen? The program will print 0, try raise exception for division error, or accepted division error. Weird. I'm not sure. The program will crash with an uncaught exception, but I imagine, well, so let's try to print 0. I had a 50-50 chance. I had a 50-50 chance. Sometimes you choose the wrong chance, Sometimes it's the wrong one. Okay, so let's see. There's a bit of an error with this error handling. There's a bit of an exception with today's episode. There's some exceptions here. So yeah, maybe just not clicking fully on this one, but I'll keep clicking off, as best I can, right? So in the code sample, what will happen? Let's see. So the program will crash with an uncaught exception. It will print 0. It will print other. Let's go for print other this time. Sweet. I had a feeling. I had a gut feeling. Okay. But why? Why is the exception? Accept exception as event. Why is that? That's so interesting, right? So interesting. Okay. So raising exception review. As you've noticed, there are many kinds of exceptions. Many specific exceptions are built into language index error and zero division error. And almost all exceptions count as the parent exception type. If you're interested in the official documentation on all the built-in exceptions, we already read that. Sorry, guys. In the code sample, what will happen? Okay, so we will print other, or the program will caught, or the program will crash with an uncaught exception. I think it will, because this is a zero division error. Golly. Unbelievable. You try to get a little momentum up and running, and golly, Guys, but we made it. We made it to the challenges. We made it to the C's, the challenges. Looks like we got 2 of these. Okay, so errors and exceptions. It seems to be an area that I need to do a little more ironing. But okay, so you've been asked to work on the checkout flow of a popular e-commerce website. Complete the purchase function. If the customer doesn't have money or enough money, raise the exception with the text not enough money. Okay, so maybe we could do something that's like, if price is greater than money available, raise exception, right? Something that don't handle the exception, wants to raise the exception. Okay, so otherwise return the amount of money the customer has left over after completing the purchase. Okay, so we'd say that, else return money available minus price, right? We'll say maybe money owed, start that at 0. If we wanted, I think we could just return this though. I think let's see if this works. Got it. We need to do that maybe, and then return money owed, just for a little bit of readability, I suppose. Boom. All right, first take, almost first take, first 1.5 take drag. 1.5 take drag. Okay, cool. So now we need to use our purchase function to process an entire list of purchase orders. Complete the make purchases function. It takes a list of purchase orders. Each order is a dictionary. Look through the main function to see what is the shape of this data. So we have price and money available. Okay, so first create an empty list for leftovers. Then loop over the list of each purchased order let's see what we got here, guys. So we'll say for purchase order in purchase orders, for each order, try to process the order with the purchase function. Interesting. So we need to purchase it. Okay. If an exception is raised. Okay. Let's stop at this bit, and then let's keep firing off here. So it looks like we need to do some error handling. So I want to print the purchase order, but I imagine it's going to be purchase order dot price. Purchase. Let's see. Purchase order price. Right. What does this argument take? It takes two things. So it takes the price and the money available. So we need to pass those things in. So I could say purchase order this ball. Maybe purchase is not defined, but it is though. But it is. Why? Make purchases. Interesting, folks. Okay, so let's try a different approach real quick. Let's reread. So create an empty list of leftovers, then loop over the list of purchase orders. So is this going to be the list of purchase orders? Okay. So we're doing that. So we're looping over the list of purchase orders. For each order, try to process the order with the purchase function. So let's just stop right there, right? So we could try to process the order with a purchase function. So purchase order dot price, right, is effectively what we want. Or the bracket syntax price and money available. So that's what we want. And then let's maybe do the error handling. So let's try that, I suppose. That's 100% what we need to do. So try and then accept, right? Purchase exception. So if an exception is raised, print this string, purchase exception error. So guys, I'm sorry, I've completely forgot the syntax for what we need to do. Raise exception, not this one, but the other one, the syntax. So accept exception as E, that's what we need. Okay, so let's see. So accept exception as E. This we could raise, I suppose, raise exception, right? Is that what it needs? So print the string. Let's see, guys. Object none type is I. So if there's not an error, because my brain is not braining, let's just see what they got here. So we have the price equals the purchase order price. Yeah, that's what we've passed in. We've passed in the purchase order price, right? The money available. So instead of assigning it to a piece of memory, we just passed it directly in. Oh, I see. We didn't do this part. We did not do this part, but okay. Because hopefully a better episode is. So we almost got it actually over here though. We weren't very far off, right? Right. We weren't very far off. I think that'll run. Sweet. So we weren't very far off. Just need a little bit of love. Then we could say leftover is this. Boom. That should work, I think, right? Sweet. We weren't far off. Okay, so errors and exceptions. We've covered that. That was a bit rough. That was a bit rocky, guys. Gonna be transparent. That was a bit rocky today. Yeah. But some days are like, you can't win them all. Can't be perfect all the time. Let's keep an eye on the challenges real quick. So it looks like we have a few challenges in front of us, and then a quiz, and then we're wrapped up with this section. So this is going to go by pretty quick, I believe. Let's look at the course overview. So we're about wrapped up. I bet by next episode we'll be done with the very first Learn Python, which guys, congratulations on making it this far and coming along the journey this far. It's huge. Sticking this far through it is certainly impressive, and it's telling of the future to come, because if you could stick with something this far, we just rinse and repeat. We ran through one course together. We'll just keep running through the courses. I mean, these should go by a lot quicker, because you can see it's a third of the lessons for a few of the courses coming up. So these will cruise through, and then we'll be on functional programming before we know it, and learn algorithms. That'll be a fun one. There'll be a lot of things that, and I'll kind of pick up a few. I've got my calendar here on the right with a few of those organizations. I have Algorithm Sundays back on the schedule. So this should work well in conjunction with that. And yeah, data structures and algorithms will be fun. This seems like it'll be a fun project, a maze solver. And yeah, and then we'll be off to the races. This will all be real fun stuff. We'll get into the JavaScript stuff, which is just my home territory, or should be, with relativity of being a dominant front-end engineer. We should be able to get some good lessons and material out of that. And then this is all new territory for me, is learning Golang, and I've mucked around with a bit of SQL. But yeah, I've mucked around with some Golang as well. But we'll get down to the nitty gritty. I've integrated Docker, but again, we'll get out into the nitty gritty of coming from this backend perspective. And I'm really excited for this Kubernetes and the cryptographies. The cryptographies, especially now when I'm going to bed to all the blockchain stuff. So this will be really fun to kind of hammer through and add to the toolkit in conjunction with Golang. So I think that's really, really powerful. It'll be a really fun system, guys. I would highly, highly recommend. They're power washing outside again, but I would highly, highly, highly recommend taking this backend trip with me. I have a series coming out called the Solidity series, and it's going to go really well in conjunction of just piling on tools to the toolkit. So I've got a ton of videos over here, a ton of material that I've lined up, and just very excited for what's to come. I've got it all scheduled, and should be a good time. So thank you for sticking by me this far, and I will see you on the next one. Cheers.